Today we're covering 1-7, which is function notation. Our learning targets then are going to be writing functions using function notation and evaluating graph functions. Graphs and functions. I think this should actually be here. All right. So function notation pretty much is the notation that you're going to be seeing from now on in this class and then in more advanced math classes as you go on. It's a very formal mathematical way of representing a function. So it looks like this. We see this fancy looking f, which stands for a function, and this is pronounced f of x equals, and then your equation. So we're used to seeing, we would write this function y equals 5x plus 3. We're just simply replacing y with f of x. Why is that? Well, this tells us clearly that this is a function of x, meaning this is our input value, and the output value, which is denoted f of x, is dependent on x for its value. So we can't figure out what the output value is until we know what x is, which is our input value. This is really nice because when you get into applications of math like physics, you can start changing these letters. So if we know that the height of an object is based in time, we want to figure out the height of an object versus time, we can name the function h of t, and then we have some equation here, and we will look at this type of equation a little bit later in the year, but this letter can kind of give you some information about what the function is about. So this stands for height, this stands for time, as opposed to always using y and x, which doesn't give you any information. So that's what the function notation is about. You can specify then input values for a particular equation in a particular way. So if we had the equation y equals 5x plus 3, and I wanted to ask you the question, so what's the value of y when x is 1? I would say something like, here's my equation, x equals 1. You would plug 1 in for x, and you would say y equals 5 times 1 plus 3, which is equal to 8. In function notation, you can say it a little bit more concisely. You can basically specify what I did here like this. This says, figure out the value of the function when x is equal to 1. So we've replaced x here with 1 here, and that means we want to replace x in the equation with whatever we have in parentheses here, which in this case is 1. So we're replacing the x here with 1 and figuring out the value. So this is basically a way of asking you a question. Figure out the value of the function when your variable, in this case our variable is x, when your variable is equal to this value, which is 1. As I said, this is the way you would say this particular equation is f of x equals 5x plus 3, and this is f of 1 equals 5 times 1 plus 3. I think this is pretty much what I told you already. F of x equals 5x plus 3 is the same as this. And it says both of these functions are the same as a set of ordered pairs x, comma, 5x plus 3. So your input value is going to be x. That's what you're going to plug into the equation. The output value you get is going to be 5x plus 3. So whatever x is, you're going to multiply it by 5 and add 3 to get your output value. So this just shows you the difference for what you're used to, the notation you're used to with y equals 5x plus 3. This shows you the difference when you're replacing y with f of x. So your ordered pair now becomes not xy, but x f of x. Okay, the graph of a function is a picture of the function's ordered pairs. So we know that, I think we know that if I wanted to graph a function like this, we probably know a lot more how to graph a function like this because it's pretty simple. If it were a more complicated function, we know that we could plug in some values for x, create a table, find the values of y, or I should actually replace this with f of x, and then graph those as ordered pairs on a xy coordinate plane. All right, first we're going to practice evaluating functions in function notation. It says for each function evaluate f of 0, f of 1/2, and f of -2. So here's our equation. And all this is telling us, here's our equation, and we want to take these and we're going to replace our x with these values. So 0, didn't do it that time. 0, 1/2, and -2. We're going to find three different values, three different output values based on the input values specified. So f of 0 means we're going to replace x with 0, and that gives us this, which means we've got 8. So we've got an ordered pair 0 and 8. Oops, I don't want that. Okay, f of 1/2 means replace x with 1/2. So 4 times 1/2 is 2, 8 plus 2 is 10. And so this gives us the ordered pair 1/2, 10. And then lastly, f of -2. I know that's a little hard to see, but we have 4 times -2 is -8. 8 times 8 plus -8 is 0. So that gives us the ordered pair -2, 0. All right, so let's find the values. So we're going to evaluate the function for these input values. We don't have an equation to do it, we have a graph, so we have to read our graph properly. So f of 0 means what is the value, the output value, or the value of the y coordinate when the x coordinate is 0. So when x is 0, we're here, and you can see that our y coordinate is 3 at this point. So f of 0 is going to be 3. F of 1/2 is actually right here, and you can see at that point y is 0. So the value of f of 1/2 is going to be 0 here. And then lastly, -2, well here we have x being -2. This is what our y would be, which is 4. So that's the last value. So you can evaluate functions from equations or graphs. And then here's our last equation. F of x equals x squared minus 4x. So we're going to plug in the values for the x values into that equation. So f of 0, we replace every x. So this means replace every single x in the equation with this value for x. So we're going to replace both the x squared, 0, and then the 4x, 0, and that gives us 0. Here we have a 1/2 squared, and then a -4 times 1/2 gives us a -7/4. And here when we replace all our x's with -2, we end up with 12. So an important point is when you're evaluating in function notation, the f of a value means replacing that variable, every instance of it in the equation, with the value that you're given. All right, in the notation f of x, f is the name of the function. Dependent variable, sorry, I'm trying to read this quickly. So your dependent variable is f of x because we can't figure out what its value is without knowing what the input value is. So your f of x is your dependent variable, just like your y is dependent variable in xy notation. Your independent variable then is x. You can make x anything, and it doesn't depend on y or f of x or anything else for its value. So when a function is graphed, the independent variable is graphed on the horizontal axis, which we normally call the x-axis, and the dependent variable is graphed on the vertical axis, which we normally call the y-axis. So just so it's clear, here's our dependent variable, here's our independent variable. So our t, we're going to graph our t values here, and we're going to graph our d of t values here. So when I plug in 0, I'm going to get 0. When I plug in 1, I'm going to get 65, and so on. So we're just trying to reinforce the concept that this is really replacing y, and all the things that you knew about y, you just transfer on to this function notation. All right, graph the function. So we're going to graph these points. Notice it's roster notation, meaning it's not an infinite set, it's a finite set. So this goes on our horizontal and this goes on our vertical. Oops. And I think you probably understand how to graph these. This is 0, 4, 1, 5, 2, 6. Whoops, sorry. 1, 5, 2, 6, 3, 7, and 4, 8. And this is important. Do not connect the points because the values between the given points have not been defined. So since we're in roster notation, it's finite, meaning we're not going to have a continuous line of data or continuous line graph because that's not part of our actual function that's been defined. The only part of our function that's defined are those discrete points. And that's what it says. A function whose graph is made up of unconnected dots or points is called a discrete function. Okay, so our last thing we're going to do is a carnival ride charges a $5 entrance fee and $2 per ride. What is the value of the function for an input of 12 and what does it represent? So we probably want to look at what the equation would be for this. So a carnival charges $5 entrance fee and $2 per ride. So our independent variable is the number of rides. Our dependent variable is going to be basically our cost. So I might say C at R, meaning cost based on the number of rides, is equal to our $5 entrance fee plus $2 per ride. So what's the value of the function for an input of 12? Cost at 12 is going to be 5 plus 2 times 12. This is 24 plus 5. It's going to be $29. So going from a word problem to function notation. Okay, local Photoshop will develop and print the photos from a disposable camera for 27 cents per print. I would like you to write a function representing this in function notation and then representing the cost of photo processing and then determine the cost of developing 24 prints. That wraps up this lesson. Here is your homework. Bring any questions to class.